Hello friends, myself R.D. Mahajan presenting my video on Fourier Series revision part 1. First example, find Fourier series for f of x is equal to x square in the interval 0 to 2 pi and hence deduce that pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on. Therefore, before finding the solution, if you are not subscribed my channel, please subscribe it and watch the video up to end so that all points are clear to all of you. Here the required Fourier series is full range Fourier series. Therefore that full range Fourier series is given by f of x is equal to a0 by 2 summation of an cos n pi x by l n changes from 1 to infinity and plus summation of bn sin of n pi x by l sin n pi x by l, again n changes from 1 to infinity, and we call this as equation 1, where we require to obtain that Fourier coefficient a0, an and bn. First step is to get the value of L, comparing that range with C to C plus 2L. Here C is 0, C plus 2L is 2 pi. Substituting the value of C as 0, we get 2L equal to 2 pi, means L equals to pi. Then, where the value of A0 is given by 1 by L integration from C to C plus 2L f of x dx. Substituting the values, we get A0 is equals to, therefore 1 by pi, value of C is 0, lower limit is 0, upper limit is C plus 2L and the value is 2 pi, and f of x is x square, its integration with respect to x. Therefore, we get that value as 1 by pi, integration of x square is x cubed by 3, limits from 0 to 2 pi. Substituting the value, we get it is 1 by pi multiplied by, for upper limit it becomes pi cube divided by 3, 2 pi whole cube means it becomes 8 into pi cube divided by 3. 1 pi get cancelled, therefore the value is 8 by 3 pi square. This is the value of A0. For this step you will get 1 mark always, if the question is for 6 marks. Then in second step we try to find out an by formula 1 by L integration from C to C plus 2L f of x into cos of n pi x by L and its integration with respect to x. Substituting the values, L as pi, C 0, C plus 2L is 2 pi, fx is x square and cos n pi x by pi, pi cancel, remaining term is cos of nx. Integrating it by generalized part, x square is algebraic term and cos is trigonometric term. Therefore, this is first term and this is second term. Integrating by generalized part, we get 1 by pi as it is, no change. First term x square, integration of cos sin nx by n, then minus derivative of x square is 2x. Integration of sin nx, next integration is minus cos nx divided by n, and this previous n, it becomes n square. Then plus derivative of 2x is 2. Next integration of cos is sine with this minus sign, therefore it becomes minus sine of nx by n cube. Next derivative 0, we stop here, and the limits are from 0 to 2 pi. Substituting the upper and lower limit. Upper limit as 2 pi and lower limit as 0. And we know the values. Sine 2n pi is 0. Cos 2n pi as 1. Then sine 0, 0. And cos 0 as 1. We require all these values. Therefore, when we substitute that upper limit, we get 1 by pi, as it is no change. This becomes sine 2n pi. And as sine 2n pi is 0, that first term becomes 0. Then minus, and this minus becomes plus. 2x, 2 times 2 pi, it becomes 4 pi. Cos of 2n pi, and the value of cos 2n pi is 1. Therefore, it is 1 divided by n square. Then minus, again sine 2n pi, and the value of sine 2n pi is 0. Therefore, that third term is 0. Means for this only we have the value as 1. And then minus lower limit, x0, 0, x0, 0, and sine 0, 0. Therefore, 0 plus 0 and minus 0. And then simplifying it, pi get cancelled. We get the value of an as minus, it is 4 by n square. That is the value of an. And if you perform these steps correctly, all the steps are correct, then you will get 2 marks for that an. Then we try to find out third coefficient bn. Formula for bn is again 1 by L, integration from c to c plus 2L, f of x multiplied by sin n pi x by L, and its integration with respect to x. Substituting the values upper and lower limit, and that function L is pi, therefore 1 by pi, integration from 0 to 2 pi, function is x square, sin n pi x by pi get cancelled, remaining term is sin of nx, and then its integration with respect to x. Again, here it is a product of two terms. The first one is algebraic, second one is trigonometric. Integrating it by generalized part, we get 1 by pi, first term x square, integration of sine minus cos nx by n, then minus, derivative of x square is 2x, next integration of cos is sine with this minus sign, therefore minus sine nx by n square, then plus, derivative of 2x, 2, integration of sine minus, and this minus will become plus, cos of nx by n cube. Next derivative 0, we stop here, and the limits from 0 to 2 pi. Substituting the upper and lower limit, we get the value of bn as 1 by pi, cos 2n pi, the value of cos 2n pi is 1, therefore it is with minus sign. 2 pi square means it becomes 4 pi square into 1, Sin 2 n pi is 0, therefore 0. Cos 2 n pi is 1, therefore it is 2 by n cube. Then minus for lower limit x0 0, x0 0 and cos 0 is 1, and therefore the terms are minus 0 plus 0 and 2 into 1, that is 2 by n cube. And if you simplify it, this 2 by n cube and minus 2 by n cube get cancelled, and therefore we have the value of Bn as pi get cancelled, 1 pi get cancelled, therefore it is minus 4 by and divided by n. This is the value of Bn. If all steps are correct, you will get 2 marks for Bn. Then substituting all these values in this equation number 1, that equation 1, substituting all values here in equation 1, fx is x square, a0 is 8 pi square by 3 and divided by 2. Summation from 1 to infinity, the value of an, it is 4 by n square. Cos n pi is by pi get cancelled, we get cos of nx only. And then Bn, it is summation from n equal to 1 to infinity. The value of Bn is minus 4 by n minus 4 pi by n into sine of nx. Equation number 2. It is the required series. It is the required Fourier series for f of x equal to x square. For this step you will get 1 mark. But as here we have to deduce some result. Instead of the 1 mark for this step, that 1 mark for that last answer. Therefore put x is equal to pi in equation 2. Why to substitute x is equal to pi? Because we want the terms alternately positive negative. And we know the value of cos n pi. Cos n pi is minus 1 raised to n. Cos of n pi is minus 1 raised to n. Means for odd we get minus sign, and for even value of n we get positive sign. And therefore substituting x is equal to pi, we get x square means pi square is equal to 8 pi square 3 to the 6 by 6 4 summation from n equal to 1 to infinity. When we substitute x as pi, it becomes 4 by 1 by n square into cos of n pi, and the second one minus 4 pi summation from n equal to 1 to infinity 1 by n sin n pi. And as the value of sin n pi is 0, this term becomes 0, and therefore we have the terms 8 pi square by 6 4 summation from 1 to infinity 1 by n square, and the value of cos n pi is minus 1 raised to n. This one is 0. And therefore, we try to substitute values for n as 1, 2, 3, so on. In this result, we get 8 pi square by 6 4 times. For n equal to 1, minus 1 raised to 1 is with minus sign by 1 square. Next, for n equal to 2, we get plus sign 1 upon 2 square. For n equal to 3, we get minus sign once again, minus 1 upon 3 square. For n equal to 4, we get plus sign 1 upon 4 square, and so on. Then, transferring this to other side, we get 4 into minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square plus 1 by 4 square, and so on. That is equals to pi square minus dividing by 2, we get 4 by 3 pi square. Then finding LCM, 3 pi square minus 4 pi square, we get minus pi square by 3. Therefore, transferring this to right hand side, we get, therefore, minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square, and so on. That is equals to minus pi square by 12. And then multiplying by minus sign throughout, this become plus pi square, this become plus, this become minus, this become plus, means we get the required result. A required answer. And for this step, that last 1 mark or remaining 1 mark, total 6 marks. Second example, find half range sine series for f of x is equal to pi x minus x square in the interval 0 to pi. And therefore, as we require half range sine series, it is given by f of x is equal to a0 by 2 summation a n cos n pi x by l n changes from 1 to infinity, and summation of bn sin n pi x by l n changes from 1 to infinity. We call this equation 1, where as it is half range sine series, a0 is 0, an is also 0, and bn is given by, formula is 2 by l integration from 0 to l f of x multiplied by sine of n pi x by l and its integration with respect to x. Where the range is 0 to l in half range, therefore we get the value of l as pi. Substituting that value, we get bn is equal to 2 by pi integration from 0 to pi, fx is pi x minus x square into sin n pi x by pi get cancelled, we get sin of nx only. Again, here it is a product of two terms of x. First one is algebraic, second one is trigonometric. Therefore, integrating it by generalized part. This is first and this is second. And therefore, be very careful while performing the integration. Don't make any mistake, especially in sign. Therefore, first term is pi x minus x square. Integration of sign minus cos n x divided by n, then minus differentiation of this with respect to x is pi minus derivative of x square is 2x, and next integration of cos is sine with this minus sign, therefore minus sine nx by n square. Keep this sign as it is, don't multiply at this stage if you want correct answer. Then plus differentiation of this term with respect to x, it is minus 2. Integration of sine minus and this minus, it becomes cos plus cos nx by n cube. Next derivative 0, we stop here. And limits from 0 to pi. And when we substitute, we are getting the term cos n pi, sin n pi. I will write down that values here. We know the value of cos n pi as minus 1 raised to n. Sin n pi is 0. For lower limit, it becomes cos 0. Cos 0 is 1. Standard values all. And sin 0 is 0. We require these 4 values. And therefore, in this step also you have to perform very carefully without any single mistake. Therefore, when we substitute x as pi square minus pi square, that term becomes 0. Minus pi minus 2 pi minus, and again this minus. 3 times minus, therefore it becomes plus. Sin of n pi, it is 0. Cos n pi, therefore it is minus 2 times. Cos n pi, the value of cos n pi is minus 1 raised to n by n cube. Then minus, for lower limit, x0, this term becomes 0, sin 0, 0, therefore first one is 0, next one is 0, third one is minus 2 times, value of cos 0 is 1, therefore it is 2 into 1 divided by n cube. And therefore, this one is plus 2 by n cube, and here it is minus 2 by n cube. That term I can take common, therefore 2 by pi into 2 by n cube I can take common. Remaining terms are here, it is a plus 1, and here it is minus 1 raised to n. And whenever we have such type of term, 1 minus 1 raised to n or 1 plus minus 1 raised to n, we require to find out two different values, one for even and another for odd. When n is even, minus 1 raised to 2 we get 1, 1 minus 1 it becomes 0, means this becomes 0 for all even values of n if n is even. And when n is odd, minus 1 raised to 1, value is minus 1, minus it becomes plus 1, 1 plus 1 we get 2, and 4 to the 8, therefore that value is 8 by n cube pi if n is even or. Means, once again I will repeat this step. because very important step. When n is even, value becomes 0, and when n is odd, value is 8 by n cube pi. And while substituting this here in this equation number 1, we have to replace n by its general term. General term for odd number is 2n minus 1. Means when we put n equal to 1, we get 2 minus 1, first odd value. For n equal to 2, we get 4 minus 1, 3, second odd value. Means we are getting only values for odd term. And therefore, substituting this value in this equation 1. Substituting all these values in equation 1, function fx is pi x minus x square, for which we require to find the Fourier series. A0, 0, an 0, that two terms become 0. Bn is 8 by n cube pi. Therefore, replacing n by 2n minus 1 cube pi, n changes from 1 to infinity. Sine of n pi x by pi get cancelled, we get sine of nx, n replaced by 2n minus 1 times x. This is the required Fourier series. Required half range sine series. And 2 marks for this last step. Total 6 marks. Last example, third example. Find Fourier series for f of x is equal to x, and in the interval 0 to 2 pi. And as the interval 0 to 2 pi, a problem is of full range Fourier series. As nowhere it is mentioned that obtain half range series. And therefore, full range Fourier series is given by f of x is equal to, formula is a0 by 2 summation of an cos n pi x by l, n changes from 1 to infinity, summation of bn sin n pi x by l. N changes from 1 to infinity. 1 mark for this. Equation number 1. And then where we require to find out a0, an and bn. And before finding that, get the value of l. Here c is 0, lower limit. C plus 2l, upper limit is 2 pi. Substitute value of c as 0, 2l equal to 2 pi, means l equal to pi. And then where a0 is given by 1 by l, integration from c to c plus 2l, f of x dx, it is equal to 1 by pi, integration from 0 to 2 pi, and fx is x, its integration with respect to x. 1 by pi, integration is x square by 2, limit from 0 to 2 pi. Substituting upper and lower limit, we get 1 by 2 pi outside. For upper limit, it becomes 2 pi square, means 4 pi square, lower limit 0, and therefore value is 1 2 get cancelled and 1 pi get cancelled. Therefore, it is 2 pi. Uh, Performing the steps correctly, you will get 1 mark. In given by 1 by L integration from C to C plus 2L f of x into cos n pi x by L integration with respect to x. Substituting value L as pi, C0, C plus 2L is 2 pi. Fx is x multiplied by cos of n pi x by pi get cancelled, we get cos of nx only. As it is product of two terms, integrating it by generalized part, x algebraic, cos trigonometric. This one as first function and cos as second function. Therefore 1 by pi, first term x, integration of cos sin nx divided by n, then minus derivative of x 1, integration of sin and next derivative 0, we stop here, and limits from 0 to 2 pi. 1 by pi, sin 2n pi value is 0, minus minus it becomes plus, cos 2n pi is 1 by n square minus lower limit x is 0 0 minus substituting value, this become minus minus plus, cos 2n pi is 1 by n square. Therefore 1 by n square minus 1 by n square, that value becomes 0. An is 0. And if you perform this test correctly, you will get 2 marks. Then we perform for Bn. Last coefficient Bn is given by 1 by L integration from C to C plus 2L f of x sin n pi x by L and its integration with respect to x. Substituting value L as pi, lower limit as 0, upper limit as 2 pi, fx is x multiplied by sin n pi x by pi get cancelled, remaining term is sin nx. Integrating it by generalized part, as it is a product of two terms. First one is x and second term as sin nx. As this one is algebraic, second one is trigonometric. And therefore 1 by pi, first term x, integration of sin is minus cos nx by n, then minus derivative of x 1, integration of cos sin with this minus sign, therefore minus sin nx by n square, next term 0, next derivative 0 we stop here, and limits from 0 to 2 pi, 1 by pi minus 2 pi cos 2n pi, the value of cos 2n pi is 1 divided by n, minus minus plus, sin 2n pi is 0 minus lower limit x is 0, this term becomes 0, sin 0 is 0, and then simplifying it we get that value of Bn as pi get cancelled, value is minus 2 by n. And for this correct value of Bn, you will get 2 marks. Then substituting all these values here in equation 1, we get the required Fourier series. Fx is x, the value of a0 is 2 pi divided by 2, an is 0, second term becomes 0, bn is minus 2 by n, sin n pi x by pi get cancelled, we get sin of nx. And therefore that series is x is equal to 2 to get cancelled, we have pi minus 2, I can take outside the summation sign, n equal to 1 to infinity sin of nx whole divided by n. is the required answer or required Fourier series for the function f of x equal to x in the interval 0 to 2 pi. And for this step, 1 mark, total 6 marks. That is the scheme of marking. Therefore, in this video, I have discussed 3 simple examples or the examples from the previous question paper. Remaining, I will discuss in my next video. Therefore, if you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.